So at the end of our last video, we looked at an example of a parametric equation. X is cosine t, y is sine t, where t goes in between 0 and 2 pi. So I wrote that down as parametric equation A. And then to contrast different examples of parametric equations, I also wrote down a few others to see how they're different. Well, remember what this parametric equation A was. It gives you the graph of a circle of radius 1 traversed counterclockwise and starting at the value x equals 1. So it's more than just a circle. If you say, oh, that parametric equation is just a circle, you're not giving me all the information I need. It's a circle drawn starting at this value. So here's my start for A, and it's traversed around exactly once. The second equation, B, also traces the graph of a circle of radius 1, but it's a different parametric equation. Here I have x is cosine 2t and y is sine 2t. And t this time ranges in between 0 and pi. This is the same basic shape. It has the same starting point, so it's the same start for A and B. If I plug in 0, I get this value. But it's traversed twice as fast. So this 2t here means that for equation B, this is the value at t equals pi over 4. So if I plug in pi over 4 for t into B, I'm at this value here. Whereas in equation A, that would have been the value I get when I stick in t equals pi over 2. So I've gotten to this point twice as fast in equation B than I did in equation A. This means the circle is traversed, again, starting at the same value, going in the same counterclockwise direction, going around exactly one time, but twice as fast. I like to think of t in my parametric equations as time. So it took twice as fast. A took twice as long as B to traverse the circle. All right, how is that different than equation C? So equation C has the same start as my previous two equations, A and B. It goes at the same speed as A, but because I'm starting at 0 and going to 4 pi, equation C actually goes around the circle 2 times, not just once. That's definitely different. Doing something twice is different than doing something once. So equation A and equation C are different parametric equations. Equation D is not the same circle. So equation D is part of a circle of radius 2. So let me draw a graph of what equation D might look like. So here is a new axis. And this time, there's 1, there's 2, there's 1, there's 2. This time, D gives me part of a circle of radius 2. Let's plug in some values. So if x is equal to 0, sine of 0 is 0. Excuse me, if t is equal to 0, x gives me 0. And if t is equal to 0, y gives me 2. So this is my starting point for equation D. So that's my start. That's my value of t equals 0. Then what happens if t is pi over 2? So if I stick in pi over 2, sine of pi over 2 is 1. So I'm at x value 2 times 1. Cosine of pi over 2 is 0. So this is the value t equals pi over 2. I'm traversing a circle, but in the clockwise direction, and the circle is radius 2. By the way, how do I know this is still a circle? Well, if you do x squared plus y squared, you get 2 sine t squared plus 2 cosine t squared. Sine squared plus cosine squared is equal to 1. So this would be 2 squared sine squared t plus cosine squared t, which would be 2 squared. And I get the equation for a circle. X squared plus y squared is 2 squared. So it's a circle of radius 2, but it's more than that. It's traversed in the the clockwise direction, and it doesn't trace out the full circle. It stops at pi. So at pi, I think I would be down here. So this would be the value of t equals pi. So I get this half, that's supposed to be a circle, of radius 1, and I'm traversed in this direction. All right, let's look at the last parametric equation E. This one is actually not a circle. This one is not a circle. Why? In this case, I have x squared plus y. I'm not going to square the y. I'm just going to do x squared plus y because I already have sine squared in my parametric equation. Then I get cosine squared t plus sine squared t. That's equal to 1. So in other words, y is equal to 1 minus x squared. That's not the equation of a circle. That's not the equation of a circle. That's the equation of a parabola. So that's the equation of a parabola. Let's draw the graph of what this parametric equation would be. So I'm going to sketch the equation of this parabola. So here's, -1. Here's 1. Here's height 1. This is a parabola that is facing down, and if I plug in x equals 0, I get 1. So it's a parabola that goes like this. That's supposed to be a parabola that comes up and goes down like that. That's the underlying shape of the parametric equation. But again, a parametric equation is so much more than that. A parametric equation has a starting point, an ending point, a direction. It just happens to lie on top of this shape of a parabola. So let's see here. Let's plug in t equals 0. If I plug in t equals 0, x is 1 and y is 0. So here's my start value. That's t equals 0. What happens if t is pi over 2? So if t is pi over 2, I get 0, 1. So here's my value of t equals pi over 2. And then you could check if I plug in t equals pi. I think I'm here. So the first half of the values, t going from 0 to pi, trace this top part of a parabola moving from right to left. So I'm going this way along the parabola. But then something happens. Between the values of pi and 2 pi, I have y equals sine squared. Sine squared could never be negative. So no y value I'm ever going to write down is below the x-axis. I'm never getting a negative. You could plot different values of t, and you could see that the parametric equation actually turns around at this point and goes back to where I started. So it turns around and goes back, landing right back where it started at t equals 2 pi. So I drew the red lines not on top of one another just to show you that they go back and forth, but really I should have drawn the line right on top of it itself. This is the parametric equation which starts at this value, goes over to -1, and then bounces right back to where it started. So that's the difference between a bunch of different parametric equations. Now, how do you plot a parametric equation in general? I mean, this one was a little bit of a more intricate example. Generally, you get a computer to plot different values of t, and then you get different points on the xy plane, and you can kind of connect them and see what your picture is doing. All right.